In a previous video, I went over my new TS100 soldering iron and my goals to make it into a battery-powered portable soldering iron. And for that project, I bought these Makita-style plastic battery adapters for drill batteries. And these come with two USB ports and a 12-volt regulated DC power jack. And instead of using 12 volts out, I wanted the maximum the battery could provide, which is about 18 volts for these batteries. So I opened one of these up. You can check out the video of that process. Basically just bypassed the 12 volt regulator and fed the battery's output directly to this DC barrel connector. So today I'll show you the results of the project, go over how it works. We have the battery clip. We have, of course, the TS100 soldering iron. And here I have a Makita tool battery, 4 amp hour, 18 volts. So these are already perfect for portable tool power, obviously, powered drill for a long time. So the missing piece was a cable to connect this stuff together. And I looked around. I have a Weller West 51 soldering station. These have these beautiful, flexible, heat-resistant silicone cables on them. I was trying to find a 2-conductor silicone cable like this, but it turns out it's very hard to find. I saw a tip online to look for tattoo machine power supply cables, and I ended up with this cable, which has so I've already cut it to do this project, but it has a mono plug, like a 1/4-inch audio plug on one end, and it has a DC barrel connector on the other end. And these also come with other termination styles, like some spring clips that go onto the tattoo machine. This one said it was 2-conductor, silicone, heat resistant, flexible, yada yada. I got it on Amazon. It was $10. It's about 4 feet of cable, and it feels good. It's flexible. It does have 2 conductors. They're pretty thin, but it's not silicone. It burns, like it ignites on its, if you hold heat under it, and it melts under the heat of a soldering iron instantly, like butter. So I'm disappointed that this isn't silicone. Beware when you're looking for these. They'll say silicone. This one smells like some kind of nylon or vinyl when it burns. It's sort of just typical plastic. So that's disappointing, but I'm going to use it anyway for now. I'll just be careful not to touch it with a soldering iron. So I lopped off the end that plugs in, I guess, to the tattoo machine power supply. And I had to terminate the other end for the TS100. Unfortunately, tattoo machines seem to use barrel jacks with a standard 5.5 millimeter output, but a 2.1 millimeter, outside sleeve, and a 2.1 millimeter inside sleeve. And the TS100 requires a 2.5 millimeter inside diameter. So I ordered some connectors also from Amazon. They come in this baggie. We have both panel mount receptacles for these barrel connectors, which I'm not using for this project, but might be handy later. And then we have these screwed together male connectors. So I use this to terminate the other end of this cable. It's already done. It's center positive, so I just kept the red conductor in here was for the center. Obviously the cable doesn't have a positive or negative polarity, but just center to center, outside to outside. Inside one of these connectors, you can see let's see if I can zoom down on this. So we have the inside conductor here as a tab, and then the outer conductor for the outer sleeve. And this has a little bit of a little clamp that you can use to squeeze the insulation of the cable to keep it from pulling out. So you solder the conductor through these holes, then you crush this around the insulation of the outer cable, the outer wire, and it keeps it from pulling out. These screw together. So in addition, I applied a little bit of super glue to the threads before screwing it together. I also put a little heat shrink on the cable to make it a little bit thicker. And I put a touch of glue on the outside of the heat shrink so that when I screwed this together, you get both the glue to resist pulling of the cable out of the housing, and then also glue to keep this from unthreading. Obviously, this isn't as strong as a molded on connector like this one, where they injection mold the connector around the cable. This is glued so that you can't, or it's injection molded as one piece, so you can't pull the cable out very easily. But this is okay. It's good for do-it-at-home projects. So now we have a cable. You can see the difference in the sizes of the inner pins of these connectors. So I'd like ideally if this had the same size connector so that I could just use this cable either way around. It wouldn't have a definite end that goes on one side or the other. It doesn't fit, like this connector for the with the larger inner diameter doesn't work very well in this receptacle, so I'm not quite sure. I would think it would fit, but with bad connection, but it doesn't even really fit in there, so maybe there's a little bit of a tolerance issue. But this right angle connector that came with the cable fits well, so I just left it on there. All right, so the project's basically done. Let's hook it up and see how it works. So I'm going to connect this battery adapter to my Makita tool battery. Obviously, if you're modifying one of these, be careful, check for that you don't have a short circuit between the terminals. This is a lithium battery. You don't want it to explode when you plug things in. I'm not sure what kind of protection they have on the inside. We hook this cable in, and then it got enough cable to reach, different projects in the field. You can set this on the ground, and then let's plug in the iron, see how it works. All right, it's powering up. It says press the button, and I think it's set to 320 right now. So let's see it heat up, see the time it takes. Great, all right, it's at 300. So we're already at temperature. I've soldered a little bit with this. I'm still getting used to this iron. It has a much finer tip on it than my Weller soldering station. But this is the whole kit, so I'm super excited by the small size of this whole setup. You can use the same tool battery you're using for a drill. This is a tiny little extra thing to carry in your kit in case you need to solder. You don't need to plug it into a wall, which is awesome. And just as a comparison, here, I'll unplug this so it powers off. I don't have a stand for it yet, so it's going to stay hot, and I don't want to accidentally set it down somewhere it's going to melt something. But I'll just balance that on top of this battery case. Could be a bad idea. And I'll bring in the Weller just so you can see a size comparison. So here's my soldering stand for the Weller soldering iron. Here's the difference in the iron sizes. The Weller is obviously designed for factory use. It's really nice fiberglass construction, foam grip for comfort. It's pretty big. It's got this wonderful silicone cable and a really good strain relief. So this is designed for many, many hundreds of thousands of cycles. And then with this soldering iron, you also have this big analog base. You can get these with a digital readout as well. This is the old school analog version. It has a beefy transformer in here. It's grounded and has a temperature control. So the total size of these two things is just massively different, especially if you don't count the battery because you're going to bring it somewhere anyway. So this is exciting, especially for small projects. Whip it out. You can do the project quickly. This is a pain to get out and put away. And you have to climb under the desk and plug it in. So this might make it that much easier to do a soldering project. I will say one caveat is that the Weller is grounded. And this is great if so it's ESD safe. It's not going to shock your circuits as soon as you touch it down. This TS100 can be grounded. It has a grounding screw on here, and it's your responsibility to connect a grounding lead to this screw and then ground yourself and your project and this iron to the same reference. So without the grounding lead installed, you can plug this into a battery like I'm doing here. The battery, obviously, as soon as you use this, battery will probably come down. I'm not sure if the tip is even isolated, but this whole system is floating to, it could be floating at a higher potential than the thing you're working on. And hopefully it'll come down to that potential. But if you want to be extra sure, just connect a grounding lead on here. So that's a little bit of a caveat. It would be nice to have a cable that does have a grounding lead, or if they had provided some way to provide a 3-conductor cable for this so that it could stay grounded. But I'm not going to worry about it. For the things I'm soldering, not too worried about ESD, and obviously be careful if you're soldering a live system. That's true if you're using a grounded iron too. It's probably not a good idea, but if you do have to solder something while it's powered on, then you might have problems because a grounded soldering iron is going to conduct ground, and then who knows what this one's going to do. You'll have a floating potential interacting with your system. So I'm super excited to carry this around and use it for small projects. Great for repairing drones. If you fly drones and you're out in the field, you might not have access to a power outlet. It's also great to just have around in a desk drawer. You can pull it out with your other box full of tools. So the total soldering kit, if you don't have a stand, I mean, all you really need is a tiny roll of your favorite solder. I'm using lead-free solder, and this iron handles it fine. Then you need your battery and your iron. So I think this project was a great success. I can post links to all these pieces. Again, it's a Makita battery clip. This is like an off-brand, and then a real Makita battery. You can find any kind of clips, I'm sure, for all these different tool batteries, different brands. So whatever brand of the day you have, I'm sure you can find an adapter like this. We're just wiring directly to the output of the battery, and then your TS100 soldering iron. Cool, that's all I have. Thanks for watching.